Hello everyone. Today we will be showing a quick demo of how to use a LabRecon chip to make a simple obstacle avoiding robot. The frame of our robot is the SparkFun Magician chassis with a MaxBotix range sensor. In order to assure that our motors have enough power, we have added a second battery pack and an H-bridge for motor control and power supply. We will begin by opening up an instance of LabRecon. Earlier today we designed this very simple palette that looks quite nice with a few gauges, wheel alignment circuits, and an LED matrix. So, as with every LabRecon project, we begin with connecting to the chip. Our connection is Bluetooth, and we go connect to COM4. Here we go. Chip hardware is found, everything is connected. Perfect. Now, earlier today, we already set all the chip pins, which we will show you right now. As you can see, our chip pin right here is distance 1, and with an obstacle avoiding robot, all you need is one distance sensor, which is great. So we go into the set, use the wizard, and set the distance. So, more importantly with an obstacle avoiding robot is the wiring diagram, because this is where you need to understand how to change things in the diagram and how to wire things together. While the diagram may look complicated, it is really quite simple. This entire section down here is simply just for using the dot matrix. So this is not necessary to the functionality of the robot, so for now we will skip it. Back up here we have the number LED reading our distance output. And then, via a series of switches and comparing modules, we output a speed and direction for both tires. The animation for tire 1 and tire 2, as well as the bar gauge for tire 1 and tire 2, are put on the end over here and facing the output of the tires. The circuit, as seen here, is really quite simple. You compare the distance to a distance of 30 centimeters, and then use that distance in a series of switches to switch between speeds. Here you can see a speed of 100, a speed of minus 75. Here is an inversion to connect to this switch. All in all, using this simple diagram, many robots can be created with different sensors. Also important to understand when making a robot is that you have to set the LabRecon chip to understand that it's driving motors. And when motors are driven, there are many options of how to do this. There's PWM, there's directional PWM, there's on-off. But since we want our robot to change direction fairly easily, we're using directional PWM. So we come up here to this little bar, and we go down to where it says 2x direction, 2x directional PWM, and 2x servo. This allows us to have 2 motors with directional ability, 2 motors with directional and PWM, which means speed changing ability, and 2 servos. There are 6 options in total, all of which allow for certain amounts of PWM, servos, and directional. But we now want the 2x directional PWM, and 2x servo. As you can see, when I turn the robot on, the wheel animations begin to turn, showing directional movement, and the speed is visible. But when the robot sees an obstacle, the wheel animations change, and the directional speed changes as well. Then the robot gets out of the way of the obstacle, and the distance sensor once again reads a value greater than 30 centimeters. Here you can clearly see the LabRecon robot driving around and avoiding obstacles with ease, all done without a single line of code. Thank you for watching this episode of LabRecon Tutorials. See you next week.